Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 25. So last time we went through a sample that was related to Canvas graphics. It was focusing on the three basic shapes of path. We had a line, a quadratic Bezier curve, and a cubic Bezier curve. Today we're going to go through another Canvas path related sample that will actually push our learning from last time further. It'll actually use line, quads, and cubics in a sort of an application that draws paths. So what I'm going to do first, though, is start with a simplified version of the sample that we're going to cover today. So we're going to be covering Hello Canvas Path, but I actually built a simpler version to get started with first. Once we get through it, we're going to go through the actual Hello Canvas Path that's included in Glimmer DSL for SWT. So let's get started by launching it. So as you can see, all it did is just draw a path, and this path is made up of lines. And if we were to look at the code, it's basically, we have a shell, meaning a window with a title and a minimum size. We have a canvas with a white background. We have a path with a blue foreground. That means any shapes that are drawn within that path will end up having a blue foreground. And then here, 100 times, we generated some data for X and Y points that are used in building a line. And that way basically built a line from here to here, from here to here, from here to here, etc., and repeated that 100 times. So that's all there is to it. Usually when you build a line in a path, you don't have to specify both the start point and the end point. You only need to specify the end point. So what I'm saying here is I want the line to end at this x1 and y1 value. So if I start with, let's just say, x is 0, for example, and y is 300. The next point could be x is 5 and y is 350. So every time I declare a line, I only need to declare the final point, and the path will automatically connect it to the previous point that was specified, the previous endpoint. So that way, the very first line declaration will automatically get converted into a point declaration. It'll think of it basically as a point, but the rest of the lines will end up being true lines that are connecting to the previous endpoint. And that's what ends up drawing this path. So that's pretty much it for drawing a very basic path. So I'm going to click reset to reset the sample into the actual real code that's included with Glimmer DSL for SWT. There you go. So in this application, let's launch it first and take a look at how it differs from the other application. So this one is drawing three paths, a line-based path, a quad-based path, and a cubic-based path. So the second and third paths are made up of curves, basically. These are quadratic Bezier curves, and these are cubic Bezier curves. All of them are covering generally the same points, but the curves have control points as well, and that ends up curving the lines, whereas here the lines are straight. And if I click regenerate, it'll regenerate a different random pattern. But again, you can see that the cubic Bezier curves are the smoothest. The quadratic Bezier curves come next in how smooth they are, and then lines are the sharpest. So how does this work? So in this example, we have a Hello Canvas path that includes Glimmer UI application to denote that it's a custom application or a custom window or a custom shell. This is just an alias for custom shell. It's got a body, and then after the body, it regenerates the data that's going to get displayed on the screen. And you saw that when we first launched the application, it generated the data and it showed it on the screen. And again, let's go through the body. We have a shell, meaning a window. It's got a grid layout, a title and a minimum size, and then we have a button, and on widget selected, meaning on click of the button, it regenerates. And that's what you saw when we clicked on the regenerate button over here. And as you can see, it actually disables it. does the drawing, and then once it finishes, it re-enables the button. That way, it prevents us from interrupting the drawing of the path. There it is. Now it's enabled again because it finished. So if we were to look into the next widget, it's actually a canvas. It's got a white background, and it's got 3 paths: path 1, path 2, and path 3. They have anti-aliasing enabled, and that's what makes the path look very smooth in general. And they have the foreground as red for the first path, foreground as green for the second path, or dark green, and foreground as blue for the third path. And then each path is preceded with a text shape that's drawing the value here of, say, line, quad, cubic. So this is basically this text over here. So on a canvas, you can also draw text. And this is how you draw text. You just make a text declaration. However, the most interesting part of the code in this application is actually the regenerate method. So let's go and take a look at it. So we have a regenerate method over here that will basically launch a new thread to avoid interrupting the GUI thread. And then in the new thread, it'll disable the button, it'll clear the paths, and you saw the effect of that already. And then for 700 times, it generates points that are used to build lines, quadratic Bezier curves, and cubic Bezier curves. And what it does is it opens the content of each path using the content method, which takes a block, and then you can add new content inside it. So for the first path, it added this line. For the second path, it added a quadratic Bezier curve, and for the third path, it added a cubic Bezier curve, and it repeated that 700 times. That's why we have all of those, variations that you're seeing over here, all the different lines, the different curves, etc. And it sleeps for a very short amount of time in between draws. So that's what gave it the sort of animation look. It's animating gradually because it sleeps for a very short period of time. And then finally, once it's done, it re-enables the button. And once the thread finishes its work, it ends, it goes away. However, if I were to close this app while it's in the middle of regenerating the data, I have code over here that is recommended to be added for real applications that will make sure to kill the thread. Or in certain real applications, you might want to save data on widget disposed while the thread is running, or maybe wait for the thread to finish, not kill it. So you could, on widget disposed, you can add logic that will happen on close of the app, and that way if you had a separate thread doing something that is in progress, it is not interrupted. Or in certain cases like here, it's actually safe to just kill the thread because we don't have any data that's going to get lost. It's just random data. In any case, if you want to learn more about Glimmer DSL for SWT, check out the GitHub project.